Okay, my friends, once again, we're back with the law of sines, and what we're looking for is we're looking for some ambiguous cases using SSA. So we're given two sides and an angle, and the two sides are connected to the one angle here. So we've done one with one solution, one with no solutions, and now, yes, without further ado, we are going to do with one with two solutions. And what does that look like? Well, how do we know? Well, first off, we realize that we have one angle and we have A and B. And so if you graph this out, what you realize, and I'll just tell you, usually it's a small angle for A, okay? Usually A, when you have two solutions, is pretty small. Not all the time, but it's kind of small. All right? And so what we have right here is we're going to have an angle A, which is going to be 20 degrees. And 20 degrees is probably going to be like something like that. All right? And so here's A. A is going to equal, whoop, all right, about 20.5 degrees. And now this is what we have is that B right here is going to be really kind of large. And we're going to make that like 31, so that equals B. But now this A is equal to 12. Now what you realize is that A is going to be less than B, but the question is it greater than H? Right here, we can find out what H is. Okay, so we have this 12, and 12 could be here. Doop. All right, so A is going to be 12. Okay, and what we have right there is if you want to just verify this, we can find out H, and so we know that the sine of 20.5 equals H over 31. All right, because that's the hypotenuse. If we have this height right there, which would be 9 degrees, and so we take 31 times sine of 20.5, and that equals H. If we go to a calculator, all right, we can take 31, and I'll just tell you it will be. And why am I whispering? I don't know, because I talk really loud most of the time. But here we go. I just want to say thanks for watching. All right, and we have 10.856. All right, which is definitely less than what we have right here, which is our 12. Okay. Okay. I had a little crash, so I tried to put everything back together. So if it seems a little bit weird, I'm sorry. But in any case, what we have right here, so now we know that there's two cases because we found this to be true. Okay. Generally, I'll just tell you once again, if this is a small angle, all right, and you have a side-side angle, you're probably looking at two solutions. That's what you're looking for. And B is fairly large as well. So what we know is that A can go like this on the outside, but also it can go like this on the inside and create this obtuse angle as well. So A can be created two different ways, one like this, obtuse, and also one, all right, on the outside. So I'm going to take that one and we'll put it right here. And then we have another one, which is going to go look like so. We go shoop, shoop, all right, like that. And so we have these two different angles that we're going to try to solve, or these two different triangles we're going to try to solve for. And so right here we have A, this is 12, this is 12, and this is 31, and this is 31. So now, for the first part, we're going to do is we're going to find out what this is. So this is B, this is C, and this is B. All right, and this is little side C as well. All right, well, we'll start with case one. We'll call it case one right here. Okay, and to figure this one out, we're going to use the law of sines. So we're going to start with case one, and this is generally what we write. We write case one or example one. We have two different things. And so we're going to take the sine, all right, the sine of 20.5, and that's going to be over 12. And let's solve for B. Let's solve for B, the B value that we have here. So we're going to take the sine of B, and that's going to be to 31. Okay? Now, from here, in order to figure this out, we're going to have 31 divided by 12, sine of 20.5, and that's going to equal the sine of B. Know that we have to solve for B by taking the inverse, so we take the inverse sine of 31 divided by 12, sine of 20.5. All right, that's 20.5, and that's going to equal the measure of angle B. So that's for case one. Now, over here, we take our calculator again and put this in here. So we take the inverse sine of 31 divided by 12 times the sine of 20.5, close parentheses, press enter, and we have an answer of 64.783. 64.783, 64.783 is the measure of angle B. Okay, the measure of angle B. Now, when you have that angle, okay, right there, that is the measure of angle B right here. Excuse me. And so the next thing is what we do is now we can solve for the measure of angle C. All right, take those two values. So from here, the measure of angle C is going to get, once again, 180 minus the quantity of 20.5 plus 64.783. All right there. And so if you would take out your calculator again, you can take that and put it in there, 180. All right, minus the quantity 20.5 plus 64.7885. All right, press enter, and then we have 94.715. All right, 94.7, what was it again? 15. All right, 15. All right, and that is in degrees. So there we found our two angles for case one, and now we're going to find out our side length. So now we're going to figure out side C. Side C, once again, so C is going to be the sine of 94.715, because that's side C, over C, and that's going to equal, let's use what we know from here, all right, the sine of 20.5 divided by 12, because that was what we were given in our original problem. Cross multiply, C is going to equal, all right, 12 times the sine of 94.715 divided by sine of 20.5. Once again, go to our calculator, clear this out, 12 times sine of 94.715. All right, and we're going to divide that by sine of 20.5. And press enter. And 34.149. 34.149. Just verify, and there we have it. Yep. And so that is the solving for case one. For case one. And that's for measure C. All right. Of all these different things. Now, the thing is that how can you solve for case two? Excuse me. What you have then in case two, all right, I'll make this in blue. So in case two, what we have is, well, we have a different angle B. B is actually obtuse. And so what we know is that this angle is actually going to be, all right, the supplement of the angle we found here. That's what we know. And so to help us find this other angle, okay, to find this other angle, what we're going to do is all we're going to do for case two, okay, for case two, is we're going to take this value right here, the measure of angle B that we found up top, and subtract that from 180 degrees. And this is one from case one. And so 180 degrees minus 64.783, that's going to give us our new measure of angle B for case two. Okay, and so once again, take our calculator. All right, you can take 180. So we're going to find the linear pair from that. 64.783. And what we have then right here is 115. All right, 115. Oh, no. All right. having some technical difficulties, so I apologize for the little bit of a delay and that break right there. But what we have right here is that's going to equal 115.2717. And you can see in case 2, that's where we have our obtuse angle. Okay, so that makes sense because now this side is going to be the largest side, for it's going to be equal 31. And so from here, we are now going to find angle C. So to figure out angle C, all right, for this number case 2, we go through the same process. We're going to take 115.217 plus, now in this case, we have right here 20.5, and we're going to subtract that from 180. So 180 degrees, subtract all that, and that's going to give us the measure of angle C, all right, angle C. From there, so if you go right here, hopefully this will work out for me. All right, 180, all right, minus the quantity 115.217, all right, plus 20.5, close parentheses, press enter, and we have, holy cow, you probably saw that, I didn't even notice it when I was going through. Make sure you don't put in extra values when you're doing that. And then you put those in there and you get your answer. All right, sorry about that. And now let's try this again, 44.283. So this angle is 44.283. That's the measure of angle C for the second case, To figure out then, okay, so we have a new angle for B. We have our third angle for C, and now we want to find out our side for C. To figure out our side for C, once again, we're going to take the sine of 20.5 because that's from our original. All right, sine of 20.5 over 12. Okay, so that's A, and we're going to take the measure of angle C, so it's going to be the sine of 44.283 divided by C to figure that out. Cross multiply, and we have C is going to equal 12 times the sine of 44.283 divided by the sine of 20.5. Go on your calculators just to make sure you can do this and verify what C is. So 12, all right, 12, that's not working out either. Holy cow, crazy, gotta love technology these days. All right, let's try it one more time. All right, 12, all right, times sine of 44. This one is not going to get a lot of views. I apologize. Or maybe it will. People will just enjoy me just talking as things just become really bad. Oh, come on. You got to be kidding me. 0.5. All right. There we go. Press enter. 23.924. All right. So we go over here. 23.924 is our side length for C. Okay. And that is for case 2. All right. And that's what we have there. So 2 different cases. The key thing is when you solve for the first one, that angle that you find is case 1. To find case 2, you take the angle B and you subtract it from 180 to find your case 2 B value, and then you solve it again the other way. So that's how we get case 1 and case 2. Same process, except the B value is going to be different for each different case. Okay. All right, so those are the 3 different ways of how we solve for the ambiguous case of SSA. I have 3 videos, 1 solution, no solutions, and then finally, always the greatest 2 solution case for side-side angle. Well, those are the videos we have. Might be some other extra videos coming up for your pleasure, but hopefully this helps you in doing your homework and your tests and your quizzes in the future. All right, good luck and God bless the rest of the problems.